Hello and welcome to SudoKanard. This is another of those puzzles that some great authors created for my birthday. And my birthday is indicated here the 23rd of the 11th month. And in Europe, we write it in this very order. So that was a very nice present from Richard Stolk from the Netherlands, one of the greatest Sudoku authors in the world. This puzzle, which is a consecutive Sudoku, and the rules are that whenever you have such a dot between two cells, it means that the digits are consecutive, and very important, all the dots are given, which means that, for example, here the digits are not consecutive. I've already solved this puzzle. I solved it more than 1 month ago, or exactly 1 month ago. I don't remember exactly. And I just remember that it was really tricky. Yes, really a tricky puzzle. I managed to solve it, but there were really tough moments in it. So I didn't solve it prior to, I didn't do another solve prior to doing this video. So I hope I won't make a fool of myself. Where do we begin with this? Well, the given digits are an indication of some sort. Well, this is interesting because here we have 4 consecutive digits, and those don't include the 2, so they can't include the 1. 1 can't be next to the 2, so 1 is somewhere in here. So that's the first thing I noticed. Perhaps I should focus on 1 to begin with. So in this area, 1 is in one of those positions. But 1 here would force this to be a 2, which would conflict with that. 1 here would work with a 2. 1 here would just work, and 1 here would work with a 2 there. So perhaps I should focus on where to place the 1s. Because of the 1s that we have, 1 is somewhere in here. But because of this 2, 1 can't be here because there's no symbol, no dot between them. But a 1 here would force this to be a 2, and that would conflict. So that's not a 1. And finally, we have located a 1 in one of those 2 positions. And we can remove this option. Sorry about that. I still have this kind of sore throat, not exactly, but I just don't know what's happening. So what else can we see? We can have a look at where 2 goes in this region, because we know that 2 won't be next to the 3, and 2 won't be next to the 1. So 2 must be somewhere on this diagonal. But if I put 2 here or there, then this will have to be a digit consecutive with 2, namely 1 or 3, which is not possible. So the 2 is here, and that's a digit. So 2 is not in here, 2 is not in here because of the digits we already have. So 2 is somewhere in here, but 2 is not next to the 1. And a 2 here would place 1 here, which would conflict. So the 2 is actually in here. And now, because of this, we have a 2 somewhere in here. But the 2 here would put, I was about to say would put the 1 in here, but actually it could be a 3. With a 3, except that this wouldn't work, because then we would have in this place a digit that is consecutive with 3, but not consecutive with 3, which is some utter nonsense. So 2 doesn't work in this place. So we have a 2 somewhere here, a 1 somewhere here. And the interesting part is, if I put 1 here, then 2. If I put 1 here, then 2 will have to be here because of the consecutive dot. If I put 1 here, then 2 won't be here. So 2 will also have to be here. So in both cases, I have to put the 2 in this place, and this is either 1 or 3. So I think I'm doing pretty well at this point. So 2 is in none of those cells, and it's also not next to the 1. So 2 is in one of 3 places. In this area, 2 is not here. It's also not next to the 1. So we are left with 4 places, but I don't think that's very useful to pencil mark. This would work very well with that, I think. So that doesn't seem to be so interesting. I won't pencil mark that much. What about this area? 2 is not in here. 2 could even be in the middle with a 1 and a 3, I think. I see no issue with that. So that doesn't seem very interesting either. So what can we see about this? Those are 4 consecutive digits. So an option could be 3, 4, 5, and 6, for example. Not the other way around, because 3 would be next to the 2. That is not allowed. And we can see that, so there are other scenarios like 4, 5, 6, 7, or 5, 6, 7, 8, 6, 7, 8, 9. There's always a 6. That's not so interesting, I'm afraid. What about this? I was thinking about this digit. If I try to make this a 5, where do I put the 4 in all of this? 4 is not here, here or there, so 4 has to be somewhere here. So that's a 4, but it's next to the 3. So that doesn't work. So that's not 5. But 4 would work with 7, 8, and 9 in here. 5, 6, 7. No, there's no place for the 4. Well, I already say that 5 is not an option. What about 6? That wouldn't work because I would need a place for the 7. And if I try to put 6 with 7 here, and that's 8, and I don't have a place for the 5. So what did I say? I said that 5 and 6 are not allowed. I would just pencil mark here the fact that 4 is okay, 5 and 6 are not. What about 7? That's the same. If I put 8 and 9 here, there's nowhere to place the 6. And conversely, if I put 6 and 5, there's nowhere to put the 8. That's really neat. And 8 doesn't work for the same reason. That can't be a 9 because there's no option for this. So that would be 7 and 6, and there's no place for 9. So 8 is also not possible. What about 9? 8 and 7 here. 4, 5, and 6. There are options for that. So there are only 2 possible scenarios, 4, 5, 6 here, or 9, 8, and 7. This is nice, I think. Let's dig further. If this is, so I just pencil mark those here, just for a reminder. If this is 4, this is 5, this is 6, sorry. 7 won't be here, so this will be 8 or 9. And so 7, 8, 9 here, that's not good. But then this will never be a 9 because we would need this to be an 8, and there would be no value for this. So in this case, it will be 7 or 8 here, and the third digit here. That's not so interesting, perhaps. So let's just write this down for 6, 6 I said, 8 or 9, 7 or 8, and let's remove all of that. So what about 9, 8, and 7 here? And this will never be a 6, but there are still... It could still be a 5. I don't think it's really useful to pencil mark all of that. So let's just stick to 4, 5, 6, or 9, 8, and 7. I think that's enough. So this here will never be a 6 or a 7, because if it were, we would need a dot between them. I'm not sure I can do a lot more with that. Let's move to digit 1 again. 1 is removed from all of those, but actually 1 is removed from those because it would need to be accompanied with a 2. So actually there's a 1 in one of those two places. So now the 2 is impossible. Well, I mean this position for 2 is impossible. And the position for 1 will dictate the position for 2. 1 here would put the 2 there, 1 here would put the 2 there. And because of this, we must have a 1 somewhere in here, but it won't be here because it would require a 2. So 1 is here, and I can remove this one here. So we can remove 1 from those. 1 here would need a 2 in this downward cell. So downward cell, I'm not sure this is a correct way of saying that. So there's a 1 in here, 2 here would work with the 1, I think. Do we have anything more about digit 2 in this area? Oh yes, we do. Because of this one, 2 can't be here anymore, so 2 has to be in here. But 2 won't be next to a 1, so it must be at one end. So this is 2, 3, and 4 in some order, with 3 in the middle. This is never a 5, because it would be next to a 4. But there are still 6 options. So now, what are those? Or is it of any interest? This could be anything between 5 and 8. Is there anything with 3 in this area? I don't think so. 3 can't be in here, it can't be next to the 2. But, oh, and 3 can't be in this cell either, because one of its neighbor would have to be the 2. So there are 3 remaining places for 3. Then again, I'm not sure that's so interesting. I'm just trying to find things, I guess. The fact that those 2 are not consecutive means that here we actually have a chain of 5 consecutive digits. I mean, in a consecutive pair puzzle, where there is no negative rule, we could have something like 6, 7, 8, 7. But here it doesn't work because of the negative rule. This would have to be a 9. Oh, but then this could be an 8. So those are not necessarily 5 consecutive digits, but those are definitely 8 consecutive digits. 4 consecutive digits, sorry. About all of those unintentional mistakes. This is where I'm getting somewhat stumped. Where is the next place to look? I know there's a one somewhere in here that's still not so interesting. We must recall that 1 and 2 here are in a diagonal pattern. Still not very interesting. Oh, with those, we can see that 3 is somewhere in here. What do we do with that? I think this doesn't work. I mean, a 3 here wouldn't work. Because then 2 must be in a non-consecutive place, so that's here. And 1 has to be here, which breaks. So I can remove this option. And that's really interesting, this configuration. So 2 here would push the 1 here and the 3 there, so that works. And 2 here would push the 1 down there, and there's no room for the 3. So the 2 is actually here, with the 1 here and the 3 there, and that's a 3 and that's a 1. Nice. I have absolutely no memory of following this line of reasoning in my previous attempt, but that looks very much like an intended argument, intended step. This 3 now removes this one, so we have a 3 among those, and a 3 in here because of this 3. The 3 is there. And if 3 is here, then that's 4, 4, 5, 6. Well, that seems to work. 2 here makes this a 1, this a 3. 2 here makes... Oh, actually, 3 here never works, I think. Yes, that's true. 3 here pushes the 1 here, the 2 here, and the 1 there. So 3 here is not an option, and 3 is actually here. That also looks very much like an intended step. But first I had noticed something with 2's. Yes, because of those 2's we can remove those places for 2, and also this because of the 1. So there's a 2 there. And there's a 3 at the bottom. But first, let's continue with this 3. The only valid neighbor is 4, so that's 4. That can only be a 5, and that won't be a 4, so that's a 6. Here, those are from 7, 8, and 9, but they're not neighbors. They're not consecutive, so 8 is not one of them. This is 6 or 8, and this is also 6 or 8. Four is not in here, so 4 is somewhere in here, but 4 is not in the middle, because then it would place the 1 and the 3, which would break. So 4 is not in the middle, so only 1 can be in the middle, and 1 is surrounded by a 3-4 pair. And here this is a 2-8 pair. Now those 4 digits are 1, 5, 7, and 9. This is neither 1 nor 5, so this is 7 or 9, and this is 6 or 8. And this is from 5, 7, and 9. And the digit that is not here must appear somewhere among those digits. Now, what about those 4 consecutive digits? They are either 5, 6, 7, 8 or 6, 7, 8, 9. So this can only be 5 or 9. The digit that is missing on the extremities here, on one end of this. So 5, 6, 7, 8. So it could be 5 and 8 with a 6 there. Or it could be 6 and 9. 7, 5, and 8. Well, nothing really interesting in there. But what we can see is that the second 5 or 9 is in here, so those digits are from 6, 7, and 8. And that is interesting because we have a 6, 7, 8 triple in this column. So those digits are from 1, 5, and 9. I'm not seeing a lot more. Trying to find something. The interesting part is that this is 5, then the 6 is in here. This is 9, then the 8 is in here. So this will never be next to a consecutive digit here. I can't do any deduction from that, I think. Oh, this one here is interesting, so that's not a 1 anymore. If this is a 1, then that's a 2, and I see no issue with that. What about 2s? So 2 is not in here. That doesn't seem to be very useful. So there's a 1 in here. So because of this, 1 is in here. And because of that, 2 is in there. Well, that really doesn't seem to be useful. We get a 2 in here, but because of this 3, that's not a 2. Two here would work with the 1, or it could work with the 3. Oh, I've been missing this for ages. This 2 makes this a 4, and that's a 2, and this 4 bounces to this place. I'm not sure that's correctly said. This 2 now removes this option, so there's a 2 in here, a 1 in there. That's not very, very interesting. Now this digit is not in here, it's either here or there. 5 or 9 would come with 6 or 8 here. This would never be a 5. If this is a 5, then 5 is here with a 6. 5 here. Well, not very useful, I'm afraid. Oh, this is not 6 or 7, because it's not consecutive with that, so this has to be from 5, 8, and 9. I'm not sure that will be interesting either. And I think this is never an 8. So why am I thinking that? Because if this is 8, then this is 6, and this here doesn't include an 8, so it will be 4, 5, 6, and it breaks. So that's not 8. The plot thickens. 5 here makes this a 9. Oh, that's it. With a 5 here, this can't be a 4 anymore, so that's a 9. So if 9 is not here, then 9 is there. So that's never a 9. Those are never 9s, so that's a 7. That's not. Then, if this is a 9, then this is 4, 5, 6, and this is 8. And this is a 5, this is 9, so that's a 6. I don't think I can do anything more with that. Actually, we know that whatever digit we have here is not in there. So 6 and 8 will both be in those cells. And something else is that because of this 4, this has to be a 4, which is much more straightforward, I think. So that's a 9 there, an 8, and a 7. This 5 makes this a 9, that's 1 and that's 5, and that's 9. So now the digit on the end is a 5, so this is a 5-8 pair. And this 6-7 pair makes this an 8, and that's a 6. This 8 resolves this 2-8 pair. Here we have 2, 4 and 7. That's not 2, that's not 7 because of this 6. Oh, and next to the 6, this must be 5 or 7. Here we have 1, 3, and 6. But for this not to work, this is never a 6. Here we must have 5, 8, and 9, but those are consecutive, so they are the 8, 9 pair, and that's the 5. Here we have a 7, 8, 9 triple. That's not 8, and because of this 6, that's not 7 either. Here we have 5, 7, and 8, but those are consecutive, so that's the 5. Here we have 4, 5, and 6, but because of this, that's the 6. That's 4 and 5, but 5 is not next to the 6. Now 3 is not next to the 2. Those two are consecutive. They can't include the 4 because 4's neighbors are here, so 4 is here, and that's a 2 up there. And that's a 3 actually. Now there must be a 6 here with a neighbor, so the neighbor will have to be a 7. And it resolves a lot. So here that's a 9 and that's a 7. Here we have 3, 5, and 9. So this is a 9. But this is never a 3 with that, so that's the 5, that's the 3. That's a 6, that's a 7. And we get 4, 7 here, 6, sorry, 1 and 6 in there. Because of this, that's not a 1, that's the 1. And because of this 2, we get the 2 in here. So we're getting there. 5 and 9 are in here. Those are 3 and 4. They are consecutive, all right. Because of this, it's this order, and because those are not consecutive. 6, 7, 8. Those two are not consecutive, so they are 6 and 8, and that's a 7. 6 and 8 here by Sudoku or by non-consecutive here. That's the 6, so this is 7, this is 9, and the rest is just plain Sudoku. 8, 5, 8 and 6, 7 and 6, and that's it. So it was indeed a tricky puzzle, but it's a really, really nice solve. That was very pleasurable. I don't remember anything that I did the first time I solved it, so it was virtually a live solve. It was a live solve, to be honest. And so thank you, Richard, for this very, very nice birthday present. And thanks again to Fabien Douté, who just requested all those puzzles. So my birthday was a long time ago, but I had to do justice to all those puzzles and the setters who created those. See you soon on SudoKanard.